A small satellite, about the size of a golf cart, just spotted a planet that shouldn't exist where it does. It's a rocky world, sitting at the outer edge of its solar system, in the exact spot where everything we know about planet formation says it should be a gas giant. And when the team tried to explain it away, they couldn't. Published in the journal Science in February 2026, this discovery is now challenging one of the most fundamental rules in planetary science. And to understand why this is such a big deal, we need to start with the rule itself. Why are Earth and Mars rocky, while Jupiter and Saturn are giant balls of gas? The inner planets formed close to the Sun, where the radiation is so powerful, so intense, that it basically sandblasts away all the gas around young planet cores. What's left? Rock. Just rock. But the outer planets formed far enough away that they stayed cold. Cold enough for gas to clump around them, piling up into these enormous, swirling giants. Rocky inside, gas outside. That's the rule. And well, it's not just our solar system that follows this rule. Astronomers have looked at hundreds of planetary systems across the galaxy. Different stars, different ages, different sizes, and again, they see the same pattern. Small, rocky planets close in, big gassy ones further out. It's so consistent that it's become a cornerstone of how we think planets are born. But one system, 116 light-years away, just broke it wide open. The star is called LHS 1903, and it's worth picturing it properly because it's nothing like our Sun. It's what astronomers call an M-dwarf, or a red dwarf star. And that's because it's smaller, cooler, and dimmer. A lot dimmer, actually, with a luminosity of around 0.05 of our Sun. If our Sun were a bonfire on a beach, LHS 1903 would be closer to a candle. It burns a faint reddish glow, and it sits about 116 light-years away from us, which in cosmic terms is practically next door. Now, scientists had already spotted 3 planets around this star using a combination of telescopes, both on the ground and in space. And those 3 planets, they were completely normal. The first one, closest to the star, seemed rocky, and the next 2, big gassy giants, just like the textbook says. So far, so unremarkable. But then the team, led by Dr. Thomas Wilson from the University of Warwick in the UK, pointed ESA's Cheops satellite at this system. And Cheops, with its extraordinarily precise eye, spotted something that the other telescopes had missed: a 4th planet, hiding out at the very edge of the system, furthest from the star. And that's where the story takes a very strange turn. Because upon closer inspection, this outermost planet, this distant, lonely little world at the outer edge of the system, seems to be rocky, not gaseous. The planet order around LHS 1903 is rocky, gaseous, gaseous, and then rocky again. As Dr. Wilson put it himself, that makes this an inside-out system. Rocky planets don't usually form so far away from their home star. Now, scientists are not the sort of people who immediately throw out a perfectly good theory just because one weird planet showed up. And so, the team asked exactly the right question. Before we rewrite the textbooks, could there be a boring explanation for this? One possibility, maybe the outer planet got hit, smashed by a giant asteroid or comet hard enough to blow away whatever atmosphere it once had, leaving just bare rock behind. It sounds dramatic, but it does happen. Giant impacts are part of planetary history. Our own moon is thought to have formed this way. Another idea, maybe the planets swapped places at some point. Gravitational chaos early in the system's life could theoretically have reshuffled the order. Maybe that rocky planet started out closer to the star and migrated outward. And so the team ran the simulations. They did the orbital calculations. They tested these scenarios rigorously, and they ruled them out. The math doesn't support a giant atmosphere-stripping impact for this planet. And the orbital timing of all 4 worlds is too orderly, too neatly arranged to be consistent with the kind of gravitational chaos you'd need for a planetary swap. So the boring explanations don't quite work, which means the team had to consider something far more fascinating. Here's the idea that the evidence seems to be pointing toward, and it's a theory that was actually proposed about a decade ago, but had never been supported by evidence this compelling. It's called inside-out planet formation. Our standard picture of how planets are born goes something like this. A young star is surrounded by a huge spinning disk of gas and dust, a protoplanetary disk, which is basically the raw material for everything. And within that disk, all the planets start forming at roughly the same time. But what if that's not always what happens? What if sometimes a star gives birth to its planets one after the other, sequentially? The inner planets form first, closer to the star, and by the time the conditions are right for the outermost planet to start forming, the system has already aged. The environment is different. The gas disk that was once everywhere has largely dissipated. That would mean the outermost planet around LHS 1903 formed late, much later than its siblings. It formed in a gas-depleted environment, which is why it ended up rocky rather than gaseous. Dr. Wilson's team calls this planet a late bloomer from another era. And that's such a precise description, because the planet is rocky not in spite of being in the outer system, but because of when it formed, after the gas had already been used up. This is a genuinely new idea being validated by genuinely new evidence. And it's extraordinary. And none of this would have happened without a remarkable little spacecraft. So let's talk about Cheops for a moment, because it deserves its own spotlight. Cheops stands for Characterizing Exoplanet Satellite. It's an ESA mission, the European Space Agency, and it launched on December 18, 2019, from the Kourou Space Center in French Guiana. It is settled on a sun-synchronous orbit at 700 kilometers above Earth. Now, what makes Cheops special isn't that it discovers new planets from scratch. That's not its job. Its job is more refined and in some ways more scientifically powerful. Cheops looks at stars that we already know host planets, and it measures, with extraordinary precision, the tiny dip in brightness that happens when a planet crosses in front of its star. That's called a transit. And from the depth and duration of that dip, you can figure out exactly how big a planet is. And that's because size, combined with mass measurements from other telescopes, gives you density. And density tells you what a planet is made of. Is it rock? Is it gas? Does it have liquid water? That's the fundamental question Cheops is designed to answer. Cheops was the first small-class mission, or S-class mission, in ESA's Cosmic Vision program. Its budget was capped at 50 million euros. Compact, efficient, and extraordinarily capable. Since its launch, it has delivered a string of remarkable finds. A planet shaped like a football, deformed by the gravity of its host star. A system of 6 planets locked in a perfect rhythmic orbital dance. And now this inside-out system around LHS 1903. As Cheops project scientist Maximilian Günther put it, much about how planets form and evolve is still a mystery. Finding clues like this one for solving this puzzle is precisely what Cheops set out to do. Cheops also acts as a pathfinder. It identifies the most intriguing worlds and hands them off to more powerful observatories, like the James Webb Space Telescope, for deeper follow-up. It's the scout of the exoplanet fleet. So let's get back to our topic. What does the LHS 1903 system actually mean for our understanding of the universe? On one level, it's a single data point, one unusual system. Scientists are rightfully cautious. As ESA research fellow Isabel Rebolledo notes, our planet formation theories have historically been built on what we see in our own solar system. And our solar system is just one example. But here's the thing. As our telescopes improve, we're finding more and more planetary systems that look nothing like ours. Systems where the gas giants are closer to the star than Mercury is to our sun. Systems where planets orbit in the wrong direction. Systems where everything is locked in perfect clockwork rhythms we never expected. And LHS 1903 adds a new category to that growing gallery of the bizarre. A system where the rocky and gassy planets are in the wrong order. Where a planet formed late in a gas-depleted environment and ended up rocky in a place where it shouldn't be. This matters because it forces us to widen our theories. Inside-out planet formation has now moved from a theoretical curiosity to something backed by hard observational evidence. And if it happened around LHS 1903, it has likely happened elsewhere too. We may just not have found those systems yet. There's also a quietly profound implication lurking here. If our solar system's orderly arrangement is not the only way a planetary system can turn out, then maybe our solar system isn't the template for the universe. Maybe it's just one of many valid outcomes. Maybe in a galaxy full of planetary systems, we're the ones who turned out a little differently. So, what do we do with all of this? The LHS 1903 system will almost certainly be studied further. Cheops has identified it. Now, the James Webb Space Telescope and future missions like ESA's Plato and Ariel can dive deeper, probing those outer planets' composition, looking at its atmosphere, trying to pin down exactly when and how it formed relative to its siblings. And the broader search continues. As we find more and more planetary systems, patterns will emerge. We'll see whether inside-out formation is rare or surprisingly common. We'll start to understand the full diversity of how solar systems assemble themselves and where our own fits in that picture. Science is at its best when a single unexpected observation forces everyone to ask better questions. The little rocky world at the edge of LHS 1903 is doing exactly that. And isn't that kind of incredible? A small satellite circling our planet 700 kilometers up managed to spot a small rocky world 116 light-years away. And in doing so, it may have changed how we think planets are born. The universe keeps finding ways to be stranger and richer than we imagined, and we keep building better eyes to see it. I'm curious, what part of this blew your mind the most? Was it the inside-out planet order? The fact that a small satellite found all of this? Or just the idea that a planet can form late, in a completely different era? Let me know in the comments.